Via its RDNA 2 architecture, advanced microdevices, better known as AMD, introduced a major innovation to discrete graphics cards, a type of memory known as Level 3 cache, which it has branded Infinity Cache. Traditionally, graphics processing units, also called GPUs, have had only Level 1 and Level 2 cache. These caches are much more local than Level 3 cache, as each group of processing cores within the GPU has its own set or shares a set with a neighboring group. However, Level 3 cache can be accessed by all groups of cores. Furthermore, because it's located much closer to a GPU's processing cores than a GPU's dedicated Synchronous Dynamic Random Access Memory, otherwise known as SDRAM, a GPU is able to process data that's stored in it exponentially faster than a GPU can process data that's stored in SDRAM. Hence, this Level 3 cache significantly reduces the latency that a GPU experiences when waiting for certain data to be transferred from SDRAM. This certain data is of two types: redundant data, which a GPU will use repeatedly during multiple processing cycles, and data that is similar to redundant data and therefore likely to be used in current or subsequent processing cycles. This significantly decreases the likelihood that a GPU will have to wait for said data to be transferred from SDRAM, thus speeding up the rate of overall data processing, that is, the effective bandwidth of the GPU as a whole. Note that the effective bandwidth of a GPU has traditionally been only the bandwidth of its SDRAM, said bandwidth being equal to the speed of its SDRAM multiplied by its bus width. With this in mind, consider that a GPU that has a smaller bus width than another GPU can function just as quickly in many scenarios, if it has Infinity Cache or some other type of Level 3 cache and the other GPU doesn't. To demonstrate this, let's compare two GPUs. Note that SDRAM's quantity is irrelevant in regard to SDRAM's bandwidth. Hence, disregard the GPU's different amounts of SDRAM. The GPUs are AMD's RX 6950 XT and NVIDIA's RTX 3090 Ti. The RX 6950 XT has 16 GB of GDDR6 SDRAM that runs at 18 gigabits per second via a 256-bit bus. 18 gigabits per second is 18 billion bits per second, and multiplying this value 256 times equals 576 gigabytes per second. As for the RTX 3090 Ti, it has 24 gigabytes of GDDR6X SDRAM that runs at 21 gigabits per second via a 384-bit bus. 21 gigabits per second is 21 billion bits per second, and multiplying this value 384 times equals 1008 gigabytes per second. As you can see, the bandwidth of the RTX 3090 Ti's SDRAM is 75% greater than that of the RX 6950 XT's SDRAM. Despite this glaring difference, the RX 6950 XT performs only slightly less than, equal to, or slightly greater than the RTX 3090 Ti. And the reason is the RX 6950 XT's 128 megabytes of Infinity Cache, to which the RTX 3090 Ti has no corresponding cache. Note that caches typically amount to only kilobytes or megabytes because they're accessed much more frequently than SDRAM, meaning that they operate at significantly higher speeds and therefore have much higher bandwidths, despite their small sizes. According to AMD, the bandwidth of the RX 6950 XT's 128 megabytes of Infinity Cache is 1,152.2 gigabytes per second. Hence, when combined with the bandwidth of the GPU's SDRAM, the total effective bandwidth of the GPU is 1,728.2 gigabytes per second. This value is 71% greater than the lonesome bandwidth of the RTX 3090 Ti's SDRAM. This information provides us with a general idea of how much greater the effective bandwidth of RDNA 3's GPUs will be, because the top chip of RDNA 3, codenamed Navi 31, will purportedly have 384 megabytes of Infinity Cache. That's 3 times the amount that the RX 6950 XT has. Assuming that it runs at the same speed, the bandwidth of Navi 31's Infinity Cache would be, well, 3 times that of the RX 6950 XT's, which means that it would be 3,456.6 gigabytes per second. Navi 31 will purportedly have 24 gigabytes of GDDR6 that runs at 20 gigabits per second via a 384-bit bus. Hence, its SD-RAM's bandwidth would be 960 gigabytes per second. Adding these two values together would equal 4,416.6 gigabytes per second. In other words, the effective bandwidth of Navi 31 could be 4.4 terabytes per second. With this in mind, please provide your opinion in the comment section below. Or better yet, register for an account at eternalgaff.com and post your thoughts on the forums. Also, please be sure to thumb this video up and to hit the subscribe button. Thank you for watching.